Hello. पहले खाने वाले क्या करना है मैंने ये टाइम हाँ ठीक है और दीजिए हाँ मेरा प्रेडिक्शन हाँ तो मैंने मेरी प्रेजेंटिंग कर रही थी ठीक है तो फिर 6 वाला वो प्रशांत कॉर्नर मेरी वही वाला स्वीट कॉर्नर
बच्चों तुम लोग इधर ही हो
मैंने बोला स्वीट से बात तो मैं ऐसे जा रही थी और विंडो सीट पे
यार तुम लोग मतलब ईद के चांद के जैसे 15 दिन में एक बार दिखते हो फिर बाद में एग्जाम चल रही कैसे एग्जाम्स कुछ स्टोरी देने लायक है
सर प्रोजेक्ट्स में 26 का
30 में से कितने मिले
27 का 20
not bad all well your side as well हाँ very good
27 है
तो इतने अच्छे हो तुम इतने ब्राव तो भी कुछ कॉन्फिडेंस आ रहा है
थोड़ा
आ जाएगा 10th आते आते पॉलिश हो जाओ लेकिन मेहनत बढ़ानी पड़ेगी ठीक है चलो सो आई एम हैप्पी फॉर यू ऑल कि अच्छा कर रहे हो तो लास्ट हमने साउंड स्टार्ट कर दिया था क्या क्या किया था साउंड में
हमने ट्रांसवर्स विद द शाइप
तो वॉइस ने तो मिस किया है सॉन्ग
we have to start the show with 5 minutes preparation
yes we'll wait for 5 minutes in the meantime I'll just play the video the last item हमने देखा था, that will help you revise and understand what is sound wave. Actually, your class is already 15 minutes behind. The real time is 4:15 in all other branches. Only in this branch it starts at 4:30. Then to some of you are not able to make it. Matlab, what is it? The school leaves you late?
Times are a bit different.
Okay, so reaching home is like latest by when?
I reach home by 3:45.
That leaves a short window. Okay. Okay. So what we are watching is how sound wave travels in a medium. Okay. So since you guys were not there, first of all, what is sound? We covered three things. What is sound? Then how it is produced?
It is a form of energy which creates sensations.
Wait. How sound is produced? Then propagation of sound. Okay, these are the three things we discussed in the last class. In this chapter, work or energy is completed. So sound is like she said, it is a form of energy. Okay, which
Creates sensations of feeling.
which creates a sensation of hearing. Okay. Then how sound is produced?
Vibration.
Yes, it is produced by vibrating objects, right? Then how it propagates through a medium. It requires a medium to propagate. Like when I am speaking, sound is produced here due to the vibration of my vocal cords, right? And it is reaching everybody's ears through air. So air is the medium. If air was not present, then you will not hear me. Okay? Now, is the air carrying my sound in your ear? So the air molecule near me are not reaching you. So what happens is the air molecule near me are disturbed. Okay? Yeah, initially it is still. When I'm not speaking, the air molecule is still. When I speak, it disturbs. So these air molecules begin to oscillate. Oscillate means they start making back and forth motion. Okay? Periodic back and forth motion. So once the air molecule near me begin to oscillate or vibrate, it disturbs the next one, then that vibrates, then the next one, then that vibrates. Okay? So what passes is the disturbance. So sound produced by me is converted into disturbance of the air molecules, and that disturbance reaches your ear. Then your eardrum gets disturbed, and that begins to vibrate. That vibration of your eardrum is converted into electrical signal, which through your auditory nerve sent to brain. And then brain picks up and recognizes that as sound. That's the whole mechanism. So propagation of sound involves basically propagation of disturbance from air molecule to air molecule. Okay? So this is what happens. Okay? Now this disturbance progresses with some speed. Okay? That is the speed of sound wave, which is about 346 meters per second, or sometimes 344 meter per second. Okay, so these values, whatever is given, it will be given something like this: 346 or 344 meter per second at room temperature. Okay, the speed increases with temperature. So at 0 degree it will be slightly less. Okay. So when the propagation happens, some of the air molecules will come closer during the disturbance because it is this kind of a motion. Okay. So some of them will come closer, some of them will spread apart. So it will form a series of these patterns before it finally reaches the ears of the listener. Okay, let's say this is the sound, and we have taken the example of vibrating tuning fork. So when the tuning fork vibrates, that also will create a sound. Okay, and it creates these regions: compression, rarefaction, compression, rarefaction, compression. So a series of compressions and rarefactions will be formed. Okay, so what are compressions? These are regions where the air molecules will come closer to each other. So it will create high pressure and high density region. Then where they are spread apart, it will be low pressure and low density region. Okay? So this is how sound will propagate. And this propagation of disturbance, right, is called wave. That's why it is called sound wave. Okay? This disturbance itself is called sound wave. Is that clear? Okay, is that clear? Now just see this video. So there are certain waves which can travel without the medium, like light wave. It can travel through space also. Okay, so that is electromagnetic wave. That kind of wave is called electromagnetic wave. But waves which require a medium to travel, they are called mechanical waves, right? And mechanical waves are also of two types. One is like the sound wave, which is mechanical wave of longitudinal type. This is longitudinal wave. So sound wave is mechanical wave of longitudinal type. There is another type of wave called transverse wave, right? So what is transverse wave? So you see, in this case, the sound is, in this case, the air molecules are oscillating parallelly to the motion of the disturbance, right? There could be other kind of disturbance which can happen vertical or perpendicular as compared to the propagation of disturbance. Like you must have seen water waves. How are water waves? Let's say there is a still surface of water, you drop a stone, then what do you see? Where the stone was dropped, the water goes up and down. So water is going up and down only at its place, but while doing so, it disturbs the adjacent water molecules. So they also slowly go up and down at different times. So what is the effect? The effect is you see that the ripples are moving outwards. Have you seen that? The circular ripple will form and then it will become bigger and bigger. So basically it is the water waves propagating like this. So if you look at one direction, this is how it will go. So is water traveling? Is water traveling in the water waves? No. It is oscillating or vibrating up and down at its place. Then what is fast? The disturbance. Each movement of the water molecule is disturbing the next one and the next one and the next one. So disturbance is nothing but energy transfer. Okay? So the sound energy is getting converted into mechanical energy and again getting converted back into sound energy. This is what is happening. So it's a conservation of energy. Understood? So wave motion is the process of mode of transfer of energy. Okay? So it's a mechanism to transport energy. Now see how sound transportation takes place. So each particle is vibrating, and it gives you a feel that the disturbance is moving. See, so you focus on the compression. Compression is going ahead like that. Or you can focus on the rare fraction. Rare fraction is also there. Okay. And it goes back. Right. Compression is moving. So you can focus on either rare fraction or on compression. Both are traveling. And it will stop traveling if the source stops vibrating. Reason for disturbance to travel is the source of sound. Where the source is the speaker. What's the answer? Is sound a mechanical wave? Yes. Why?
It needs a medium.
Correct. Because it requires a medium to travel. What's the medium that we saw? Air. Okay. So any wave which requires medium to travel is called mechanical. Now, even in the medium, how the molecules of the or the particles of the mediums are disturbed. On that basis, there are further categorized. A mechanical wave of longitudinal type or a mechanical wave of transverse type. So in the transverse wave, the disturbance is perpendicular to the motion of wave. Okay, so this, like I said in case of water waves. So water waves are traveling in this direction. But how is the water molecule vibrating? Perpendicular, up and down. So therefore, this is transverse wave. Okay, and here it is longitudinal wave because the molecules are parallel to oscillating parallel to the propagation of disturbance. So far, so good. Okay, let's go further. Okay, so I think we are done with the video. Now let's look at some terms associated with wave motion. So, what did we say? Wherever there is compression, the pressure and density is high. Correct? So, we can create a graph of pressure or density or displacement versus time. Okay? So what is this graph about? Pressure, density, and displacement. P is pressure, rho is density. This is called rho, and x is displacement. Right? So you can represent the graph like this. Okay, and so on and so on. Okay, this is time. So let us say this is the main position of the molecule. This is the main position of the molecule. So initially when there is no wave motion, the molecule is still. When the wave motion starts, so from the main position it goes to one extreme, comes back to main position, again goes back to other extreme, and then comes back to main position. This is one oscillation. Okay? Like if you look at this, let's say this is a pendulum, right? So when I set it in oscillation, how can I set it in oscillation? I'll hit it, because this is its main or rest position. So it is going on both the sides, correct? So this is one extreme, this is the other extreme, this is the main position. So what is one oscillation? One extreme, other extreme, and this. So there are 4 steps. 1, 2, A, and this is B, right? So this is how it is. A, then A2, इसको अगर तुम O मान लो center. O to A to O, then again O to B, then B to O. It's like this. Okay, A O, O B, B O. The motion started from O, okay, and then again back to O in the same direction. Then it is one oscillation, 4 parts. Okay. So O to A is maximum displacement. X is maximum on one side. So this is called displacement. So plus A and minus A. So this we call amplitude. What do we call it? Amplitude. So it is the maximum displacement. What is it? Maximum displacement of the particle of the medium, okay, from its main position during wave motion. It is the maximum displacement of the particle of the medium from its mean position. One second. Hello. नहीं लेक्चर दे रहा था किस बारे में था? नहीं वो you were just checking the by mistake दिया है. हाँ वो by mistake. चल ओके. Okay, so it is the maximum displacement of the particle of the medium from its mean position. You are not sitting in a classroom, not your phone. Okay, so it is the maximum displacement of the particle of the medium from its mean or rest position when during wave propagation. During wave propagation. Okay. Before that, I should also write oscillation. What is oscillation? Or vibration. How do we define the oscillation or vibration?
To and fro motion or
Periodic. It is
periodic.
it is periodic. Okay, to and fro motion. To and fro motion about a main point. About a main point. Excuse me. So there is a difference between a periodic motion and a oscillatory or vibratory motion. What's the difference? A periodic motion is the one which repeats itself after fixed interval of time, like Earth rotating around Sun. So it takes a year for Earth to complete one revolution around Sun, and again it will take one more year to do the second revolution. Correct? Or if it is spinning around its axis, it takes 24 hours. So one full rotation. So that's periodic. So what is the period? 24 hours or 1 year, and then it repeats again. But what is oscillatory motion? Oscillatory motion is not in one direction. Okay, it is changing direction all the time. But this is also periodic, meaning to complete one oscillation, it always takes same duration, same time interval. Is that clear? Each vibration takes place in the same time interval, and that is called time period. What is time period? It's denoted by capital T. It is the time taken it is the time required to complete one oscillation or vibration. What is the difference between oscillation and vibration? Are both same or different? Like how?
You told last class, 1 second, I remember this.
Yes.
So the effect.
You was not there. You were very much there last time.
You was there.
अरे मैं पिछले वीक के 2 क्लास में
Okay, ठीक है.
अरे मेरी इंग्लिश को क्या हो रहा है?
Oscillations are the time periods are large.
So the effects are different.
Huh?
Christy.
Oscillations has large. It takes large time duration to complete one oscillation, like a pendulum of a clock. You can see when it is completing a vibration, when it is completing one oscillation. But have you seen how the shaving machine needle goes up and down? It's so fast, right? It's pretty fast. So it goes up and down very fast. That is called vibration. So for vibration, the time duration to complete one vibration is very short as compared to oscillation. That's the only difference. Both are to and fro periodic motion, but the time period involved are very small in vibration. Okay. All right. Then we have what is called as wavelength. So what will be the unit of amplitude? It is the maximum displacement, right? So displacement unit is meter. Meter. What is the unit of time period? Second. Unit of time period is second. Next is frequency. The symbol for frequency is nu. It's read as nu. Okay, it is read as nu. It's a italized V. So what is frequency? It is the number of oscillations or vibrations in 1 second. Yeah. It is defined as number of oscillations in 1 second. Defined as number of oscillations in 1 second. So, what is the relation between time period and frequency? So put it on silent. Even I have put my mobile on that. What is the relation between time period and frequency? What is time period? Duration for one oscillation. And what is frequency? Number of oscillations in 1 second. So frequency is equal to 1 by t. If t corresponds to one oscillation, t second corresponds to one oscillation. Therefore, 1 second corresponds to 1 by t oscillation. So this is the number of oscillations taking place in 1 second. So this is the relation. Frequency is reciprocal of time period. So what is the unit of frequency? What is the unit of frequency? Per second, right? Per second, or it is also called as hertz or hertz. It is the name of the scientist. Okay. So unit of frequency is 1 by second, which is per second, and this is also known as hertz. The next is wavelength. And its symbol is this, and it is read as lambda. Lambda. Okay, Greek letters. Now, I think we have many funnily sounding, what do you call it, characters in our script going from Kashmir to Kanyakumari. So many of them are there. It's opposite Y, right? Y got entire. And it represents wavelength. So what is a wavelength? Now look here. This is one oscillation, right? Or one cycle also. So it is also called as vibration or cycle. Oscillation, vibration, cycle. One and the same thing. Cycle because it repeats. Okay? One cycle is completed, second cycle. So that's why the unit of frequency is also cycles per second. Vibrations per second or cycles per second. Okay? Cycles per second. Okay, so what is wavelength? It is the distance traveled by the wave during one complete oscillation. What I mean is, when the air molecule goes like this, by the time it completes one vibration, the disturbance from this particle reaches the particle over here. Understood? Because air molecule is not traveling. When the air molecule completes one oscillation, the disturbance is already disturbed some molecule after a distance called wavelength. Okay? So you can say it is the distance traveled by the wave any disturbance during one cycle. So what is the time taken for one oscillation or vibration? T. Huh? T is the time taken to complete one oscillation. So in this time, whatever distance the wave travels is called wavelength. Okay? So now, and what will be unit of wavelength? What is unit of wavelength?
Lambda.
That is symbol. Unit is, it is distance, right? Distance is measured in meter. So we'll restrict ourselves to SI units. Okay, now wave speed. What is wave speed? Wave speed is distance upon time, correct? V is equal to distance upon time. So distance traveled by wave upon time taken to cover that distance. So what is the distance covered?
Meter.
If it is lambda, then the time taken is time period, isn't it? When the distance covered is lambda, then the time taken is time period. Therefore, V is equal to lambda by T. And what is 1 by T? Frequency. Or V is equal to mu. Okay, so it is represented by both the formulas. So speed of wave is given as frequency of the wave times its wavelength, or wavelength divided by time period of the wave. Okay, this is all. Okay, is this clear? And what is the unit of speed?
Meter per second.
Yes. Meter per second. Okay, this is what is. And then there is this experiment. Did I discuss this experiment? That sound requires medium to travel? Last class. This is the experiment. We'll demonstrate that sound cannot travel without a medium. I will discuss this today before closing. But this is the most important part of this chapter. All the numericals will be on this form. Okay? Yes.
Sir, do we have that exponents value question in this chapter?
One figure physics, maths.
Sir, that exponent.
Yeah, maybe. Why it is bothering you?
Sir, this time a question came which was of 5 marks.
Hmm.
And was 5 marks.
And you're so happy about it.
I don't know how to do that. I can answer in bar.
So when you have questions where you're stuck, you can bring it in the class, you can ask. Rather than glorifying about your failures, ask questions. Okay? So that you will learn about it. Okay? So where is that question? That is the more sensible thing. Bring the question, learn about it so that you don't repeat it next time. That should be the idea. So let's see that without medium sound cannot travel. Right? Can I erase it? Okay, one more thing we should have covered here. This, for a transverse wave, this peak. So there is a peak and there is a valley. This is a valley, right? So wave is also like a series of peak and valley formation. Isn't it? A wave is nothing but a series of peak and valley. So this peak is called crest. Peak is called crest. And valley is called trough. Crest and trough. This is the term used to describe transverse wave. Okay? I have used the same diagram to represent both transverse and longitudinal. In case of longitudinal, I will consider pressure and density. Okay? So, wherever the pressure and density is maximum, okay, it will be called as compression.
Sir, what is C dot P dot S?
C dot
P dot S.
Cycle per second.
No?
over there.
Per second.
This cycle per second. Okay, compression. And this thing is called rarefaction. Remember CR, compression, rarefaction. So wherever the pressure and density is low, okay, that is called rarefaction. So same wave is representing both. What are the two types of mechanical waves? Longitudinal and transverse. So जब भी transverse रहेगा, we will use the term crest and trough to represent peak and valley. And whenever there is longitudinal wave, then we will refer compression and rarefaction. For high pressure and density, compression, and low pressure and density, rarefaction. Is that clear? Because y-axis is representing pressure and density. And if it is displacement, then the going up and down during transverse wave, then it is displacement, and that displacement is representing crest, the peak and the valley. Is that clear? When you do it again and again, it will become clear. Since waves are just introduced, it's pretty new for you. Okay. So are we good till here? Just write it down. Crest, trough. These terms should be plain in your mind. Crest, trough, and compression and rarefaction. Okay, let's discuss the bell jar experiment to demonstrate the requirement of medium for propagation of sound. So bell jar. So you have how the bell looks like. Bell looks like this, isn't it? So let's say this is a bell jar. Okay. And here you have fixed a cork. And through the cork you hang the electric bell. Okay, so this is electric bell. And some electric connection is provided. Okay. So when you switch on the bulb, when you press the switch like we pressed just now, this hammer will hit the metallic gong. When it hits it, a vibration will be created here, right? So if there is air, that vibration will travel and it will vibrate the glass surface. And this vibrating glass surface will vibrate the air further, and the listener will be able to hear the sound. Okay, as long as there is air. Now let us say a vacuum suction pump is connected.
Suction.
Point है
Pump.
वो क्या होता है?
The air will be sucked out. So slowly, when this pump is put on, vacuum pump, every house has a vacuum pump, right? It sucks dust and air, right? But if the chamber is closed and you are sucking the air from it, then there will be a situation, no air left. Okay, no air left. So you will see, as the air is pumped out, while the bell is ringing, it goes dimmer and dimmer and dimmer. And then you see that the bell is ringing, but the sound is not heard. Once the glass jar is completely evacuated, the sound is not heard, despite the bell ringing. Why? Because there is no air molecule, so the vibrations are not reaching the jar. Vibrations are not reaching the jar. Is that understood? So this demonstrates that without air, sound will not travel. Okay. So you can read the description and I'll explain in the next class.
आता हमारा सवाल
अबे यार ये जो आंटी उसको फर्स्ट ईयर सिलेबस में और ये बड़ी टॉपर है इसको सुना वो पता है उसका सही फर्स्ट नंबर आता है एकेडमिक्स में 98-99% भाई ईशा 2.2 भाई ईशा 2.2 पर मतलब उसकी बेस्ट फ्रेंड के साथ आप उसकी क्रिया कर क्योंकि उसको भी भाई को मेरे को बताओ राजश्री को क्या हुआ था हाँ ये हाँ अच्छा ये भी मेरे को बंदी की चुगलियां करती है मतलब अभी तुम्हारा साथ पीला कैसा लगता है अरे भाई तू क्या जानेगी उसकी तू तेरे बाल है मैं भी नहीं पहले तू बता क्या लड़की से बाल काटे वही दिख रही है साइड में क्या तो बाल में काट देती बाल नहीं मैं सरारी कर जाऊंगी क्योंकि ये ना क्वेश्चन तू काटे से मुझे कुछ खाने नहीं है तो खाने के लिए थोड़ी ना खाते हैं कभी पढ़ाई नहीं यार मैं टेस्ट देने चली गई थी ये देखा जवाब मैं टेस्ट देने चली गई थी वरना मेरे को भी समझ आ जाता क्या हुआ अभी तेरे को पता है मैंने भी ऐसे ही पता है अच्छा और मेरे पास जरा थोड़े से बाल पीछे से मैं कोई ऐसा काट नहीं करती सुनना तुमको बाल करवाने हैं ये बाल मेरे को इतने दे ठीक है और ये बाल भी मैंने काटे थे ठीक है इस साइड से तो मेरे को लगा कि नहीं अच्छा नहीं दिख रहा तो मेरा कोई नहीं मैंने बचपन में मेरी मम्मी कहीं ट्रिप पे गई थी और पापा अकेले थे तो मेरे बाल जो बैंग्स थे यहाँ तक आ गए थे तो वो यहाँ ऐसे आ जाते थे तो वैसे तो उनको यहाँ से कट करते थे तो यहाँ उठाते थे तो मैंने भी और वो अभी है भाई ये वही है बाल मेरे को पूरा ऐसे पीछे सिर में लगा के हां तो जैसे ना अब मैं तो छोटी भी नहीं थी मैं फर्स्ट 8th के लास्ट टर्म का था तो मैंने इधर से अपने बाल काटे हां तूने बताया था मेरे को यहां से भी बाल काटते वक्त भी सोचा कि रहने देते कि इतने अरे नहीं यार मारे भी देते नहीं मारे वही होगा इसमें बहुत चिल्ला सबके मार्क्स देखते हैं और बहुत लग रहा है भाई टेस्ट देने वाली का बिना कितने बजे रिपोर्ट करने के लिए भाई